So good afternoon, everyone. There you go, mic's up. My name is David Rubel. I'm with AWS, and I am a Senior Business Development Manager focused on DoD Secure Hybrid Edge Solutions. Joining me here today is two gentlemen from Leidos, Bert Atkinson and Charles Ott. Our contact information is going to be in the last slide of the presentation, so that will be provided for you. And the topic today is one that's really exciting. It's about really how to build a tactical hybrid edge cloud with Leidos and AWS. So let's get started. So first, who is Leidos? So Leidos, the name out there in the industry, Leidos is a company of over 40,000 employees, roughly about $14 billion in revenue. Majority of those folks are cleared, definitely well known in the DoD and NatSec space. And the folks that we have here today are focused on this particular space, so we're very happy to be sharing this conversation with Leidos here today. So the conversation really begins with what is edge to cloud? And as we look at this, we start to really think about the traditional way that services are built on AWS. So the requirements historically have been to build in the cloud and then leverage those native services in the cloud. But we do know that there is some data, there are some applications that have to stay on premise, or there's even some applications that have to be served further down the line and from a user perspective at an edge environment, potentially a tactical or extreme edge, and even potentially operating in a completely disconnected environment. So this lays the backdrop for the continuum from the AWS region, extension of that AWS region instantiated in the services that we're going to be discussing here today, Outposts, Wavelength, which is our 5G service extension, and also local zones, which is focused on low latency applications in geographies. Then the Snow Family. So the Snow Family is designed specifically for that disconnected, tactical, rugged environment. So really, as we look at the set of requirements across the board, this approach, this set of capabilities and the architectural approach helps address the needs of that entire continuum. So if we look at the AWS Amazon services together, we see kind of where the pieces fit. So again, going from the AWS cloud, again, native services, roughly 190 to 200 services, always increasing. The metro centers is where something like the local zones would apply. Again, focusing on those low latency set of requirements. In the on-premise space, Outposts. So the Outpost system is a service that was designed specifically to be an extension. The same hardware that AWS uses in the regions today is now extended onto the customer premise in the data center. And the rugged edge. So we talked about the Snow Family. So this is an evolving area where the set of requirements traditionally are associated with rugged extreme environments where size, weight, and power is really important, but also the rugged nature of that environment requires a rugged solution, something that can be easily supported, but at the same time is meant to operate in that extreme environment, including vehicles, airplanes, airframes, and so on. And then as we start to talk further about different possibilities, 5G is an important kind of disruptive technology and set of capabilities now, kind of extending that now into that edge conversation. So what does that mean now to be able to offer AWS cloud services through a population of 5G users, or maybe in a disaster scenario or in a military operations scenario where there is no infrastructure, but yet there is a need for AWS cloud services over something like 5G. So the overall approach from AWS is really to design these sets of services in this continuum with basically 5 pillars in mind. And the area of commonality here is associated with the common user experience. So as you're building your applications in region, deploying them, building them in the region and then deploying them in a hybrid environment and then further deploying them in the edge environment, it allows you to build once and deploy many and many in that continuum. So the key development tenet here is design these hybrid cloud and edge solutions with the same level of reliability, the same user experience, a set of services that are applicable for that particular stage, that particular environment, and then make the tools, the same tools that you use today in AWS, the things that you have incorporated to automate your cloud journey and even your use of cloud services, continuous across the board. So we'll start here looking at the AWS Outpost rack. It is, as I mentioned, the hybrid cloud service offered by AWS. There is an AWS rack here, as you see the picture provided. There's one down in our booth, and also Leidos has one deployed out in Sterling, Virginia. And by the way, they were the first to deploy an Outpost rack in a GovCloud environment. So the Outpost rack is a 42U rack, and the hardware of the Outpost is exactly the same as what's deployed in our Amazon availability zones. So the consistency of hardware support, the high level of performance from our own proprietary Nitro hypervisor gives us incredible performance, and then extending that onto the customer's premise. It is a managed service, so it rolls into the data center fully assembled. It is a managed service, so we maintain it, we patch it, we update it. If there's a problem, it's our people that come out and fix it. We do give the keys to the customer, but it's only for safety reasons. So the whole focus is on that capability and delivering that capability in a sustainable way, and allowing it to connect into the current data center environment, the current customer networks. So it's built with disaster recovery and redundancy in mind. That's at every level, and it really starts at the way that we distribute power in the Outpost. Traditionally, when you walk into a data center or traditional OEM equipment, you have two power supplies that balance the system. Here, we actually take an AC feed and convert it across all of the servers or the droplets in the Outpost. So that way, serviceability becomes very, very easy. The uptime of the system is really incredibly increased, and just the power consumption has dropped. So there's a real advantage in this approach architecturally from a hardware perspective. And then finally, redundancy. Redundancy from a connectivity top of rack switches in terms of connecting to the customer's environment. 1 gig, 10 gig, 40 gig, 100 gig connection to the data center network. So as we're talking about this continuum, the Outpost that we discussed in that hybrid cloud space, now in the edge space, some of the key value propositions here are about delivering services to the edge, delivering infrastructure services, things like compute and storage, and also a subset of services that are applicable to the edge. Here at AWS, we always develop from our customer backwards. We always start with the customer's requirements in mind and come back. That's why you don't see services just kind of thrown out there and saying, well, build it and they will come. That's completely not our approach. So the services that you see in these systems, the Snowball Edge, the Snow Cone, which is its smaller version, you can again see these down in our booth, and the Outposts are built with that in mind. So it does provide that edge compute and storage capability in times when maybe there will be no connectivity to the cloud, so they have to operate completely autonomous. And then be able to support those services at the edge and then decrease the amount of time from data to decision. So think of IoT sensors at the edge and performing that analytics at the edge instead of having to ship that data up somewhere for analytics to be able to make that decision. So the Snowball Edge significantly decreases that amount of time from data to decision. It's built with security in mind, and like I said, it's a rugged package. These are meant to operate in extreme environments. And then security. They're built with key management system. They're built with, just from a physical perspective, tamper protection. Encryption is part of the way the data is managed in Snow devices. So you're in that disconnected or that austere environment. The requirement is for a high level of security, a high level of physical security, and a high level of localized performance from a compute and storage perspective. So with that, I'd like to hand it over to Leidos for the rest of the presentation. Gentlemen.
All right. Thank you, Dave. As Dave said, I'm Berg Atkinson. I work in the Digital Modernization Accelerator in Leidos, and I'm going to talk to you about our Edge to Cloud R&D project, which has gone a little bit beyond R&D now, starting to get some customers going. So, what problems are we trying to solve? There's basically a puzzle. It's a puzzle out there, right? On-prem, edge, cloud, and everything that's on top of it, right? The communications, automation, acquisitions. The way things are done now creates a lot of silos. I think we've all heard about silos. We've all experienced some silos before. Your data ends up being segregated and isolated, and there's a lot of data out there. So there's a lot of things we have to deal with. And the human in the loop slows things down too. So we really want to try to address that by unifying all these different puzzle pieces together into an ecosystem, and that is edge to cloud. So where did this concept come from? We are somewhat DoD focused in where we have come. Charlie's a veteran, I'm a veteran. So we've worked in the defense group within Leidos for a long time. The impetus of this idea came from a speech that Major General Peter Gallagher gave a few years ago. He was the network cross-functional team lead up at Aberdeen Proving Ground. And he said, our vehicles, platforms, air-ground integration, everything has to be an ecosystem. And so that got us thinking about how do we put all these puzzle pieces together? How do we create an infrastructure ecosystem that can sit under all these different applications and things that a customer may need. So again, like I said, the challenges were those stovepipes, especially for DoD, stovepipes, lack of interoperability between legacy systems. There's a lot of siloed systems, a lot of large programs of record, a lot of legacy applications out there. And that creates the inability to conduct multi-domain operations. So one of the big pushes in DoD right now is Joint All-Domain Command and Control, JADC2, or otherwise known as multi-domain operations. And they really are looking to try to unify the way the services work together. So we thought about this problem and came up with Edge to Cloud as our way of trying to address this. So what we did, we partnered with Amazon because they're leader, frankly, in the DoD spaces, certainly on the classified levels. They operate at secret, top secret, unclassed, and they have a very mature capability. They are ahead of the other cloud providers. But we not only partnered with them, we brought in HashiCorp, because we use infrastructure as code as well, so we're tightly partnered with them. Telos for developing our IAA packages to submit. GitLab to do all our task tracking, management, CI/CD pipeline, and Rancher Federal to provide the Kubernetes platform that we layer across all of the Edge to Cloud nodes, basically. So it's been about 18 months that we've been doing this. We're pretty much have V1 built and ready to go, and we'll show you some of what that looks like later on in the presentation here. All right, so what is Edge to Cloud? As I said, we're trying to create this architecture ecosystem that allows you to deploy all those legacy applications, as well as maybe re-platformed containerized applications and new modern containerized microservices, and try to weave all of those together. So Edge to Cloud is a resilient command, control, and compute ecosystem enabled by DevSecOps and resource provisioning processes like infrastructure as code, like configuration as code, to securely connect all these platforms, software, services, and all the data via vendor interoperable infrastructure. And the vendor interoperable part means that we do need to be able to operate with other cloud service providers, other hardware providers, Dell, VMware, on-prem kind of solutions, not just AWS. I hate to say the Azure word in here, but the government is heavily using Azure as well. So the ecosystem itself needs to be able to span all of these different types of architectures. So we really are trying to extend that compute power and storage that you find in the cloud down as close as we can to the edge to enable us to do more advanced maybe signal processing or imagery analysis, different types of things as close to the edge as we possibly can. So that's Edge to Cloud. This is our view of the ecosystem. This is how we broke it down into layers. Our layer 0 is really where as we call the tactical edge. And we again are trying to do as much processing down there. So we'll have things like the AWS Snow Family. This is all really, it's a resource-constrained environment usually, and we have to be ready to operate in a disconnected, intermittent and latent environment at the edge as well. So we're using things like the snow cones. We've done Raspberry Pis, NVIDIA Jetsons, just standard Dell equipment that you could put on an edge. Any smaller form factor, because we're usually, again, constrained by size, weight, and power, as Dave said out there. So we're trying to make it as compact and as small as possible. When we move to layer 1, that's where we're getting into a little bigger form factors, something like an AWS Outpost, like he was talking about, or snowballs maybe. Snowballs can kind of reside at layer 0 or 1. It's a little bit fuzzy at times, and depending on the customer or where you want to deploy things, you may want different capabilities at different locations. And some customers may have different size, weight, and power requirements that you can do on those different layers. When we go over to layer 2, that's where we're really that's the transition from the edge to the cloud. So layer 0 and 1, we consider the edge, and then layer 2 and 3 is what we're calling the cloud. So layer 2 is really like the AWS region. So it would be like a US Gov West or a US Gov East, kind of one of those isolated regions within a cloud platform. And then layer 3, that's the whole, that would be like AWS Gov Cloud or AWS Commercial or GCP or Azure. It's kind of it's our abstraction for all of the other different cloud providers that are out there too, that we would need to be interoperable with. So here is an Army example. Like I said, we've kind of come out of the Army, and so some of the main people we've been talking to and helping to drive the requirements have been out of the Army. So we've developed this with a good amount of feedback from the Army itself, but also other parts of DoD. We've talked to a lot of them. However, I do want to kind of foot stomp that we're talking about an infrastructure ecosystem. It's not solely focused on defense, right? The infrastructure and the ecosystem itself can be applied to defense, civil, health, intel, kind of whatever sector, right? Anywhere you need to perform digital modernization. That's really what we're trying to bring those modern processes and help DoD first, because they need a lot of help in modernization, but we're really trying to help them modernize their processes and the way they do things. So again, over on layer 0, these are the kind of things that you would find out there in an Army kind of model, right? We have a lot of different sensors. Every soldier is a sensor is a big phrase that the Army uses a lot. You have UAVs, so there's tons of full motion video flying around, imagery. That's really saturating comms too. I think it's something like the statistic of 80% of tactical comms in the Department of Defense are eaten up by streaming video or imagery. It's a lot, right? So what happens if we can do that processing down at the edge? So if, for example, I could take an FMV stream and maybe do some exploitation on it at the edge, have a machine learning or AI algorithm looking at that for me, or the imagery and doing identification, maybe I only need to send back a little bit of that video instead of streaming video all the time back. And you're not always able to. Again, disconnected, intermittent, latent, I might not be able to stream anything back anyway. And I still need to get some kind of processing done on that edge. So we think if we can actually do that processing close to the edge, we can also take some of that load off the comms pipes. That's definitely a concern for just about every customer we've talked to. You want to push more stuff over our comms pipelines. Well, we're like, well, no, not really. We want to push stuff out that can then enable you to take the pressure off of those comms pipelines. So between layer 0 and then the transition to layer 1, as I said, that's a larger form factor. That might be something like a more permanent forward operating base, just a larger construct than the very tactical edge there. And usually that will have some reach back, so it has more capabilities, so you will be able to have more processing capabilities, data exploitation, and dissemination kind of capabilities from that layer. And then, like I said, moving over to layer 2 there, that's where we get into kind of the regional cloud, where it would be something running in US Gov East, West, and then on to layer 3, where that would be the joint or kind of interagency operations that we want to enable when we're going across the different cloud service providers. Because some of the 3-letter agencies may be running one, Air Force may be running another, Army another. And so what does this enable? So this is what we think the edge to cloud infrastructure enables. The unification of all those legacy applications out there. The Army itself has 11,000 applications, just the Army. Not all of those are going to get modernized. Not all of them are going to get refactored. It would probably take 1,000 years and way too much money to refactor all of those. So how do we enable those legacy applications to reside in an infrastructure and work nicely with maybe some of the other legacy applications or newer, more modern applications that may be containerized or sitting in a container somewhere. So we really think the containerized microservices piece helps us bring together those 3 different layers. I know DoD, this is how those things interact and how they play together. That is one of their big hot buttons. We recently, our CTO of our company recently talked to effectively the CTO of DoD, and this was her number 2, was how do we take all these legacy applications and continue to get them to work with the new things that we're developing. So we think this is kind of how you solve that puzzle, right? How can we put those pieces together so we have legacy applications, brand new containerized microservices, and we're using those containers to the microservices to really bridge the gap, right? We can enable capability from one legacy system to another, and we can rapidly develop containers and microservices that enable communication maybe between those, expand their capability without actually having to do anything to legacy application itself, which is sometimes an ordeal in DoD to change one of these big, large legacy applications. The fire control system for the Army and the Marines they use for artillery, I think it's written in about 30 different programming languages, and one of those is Ada, which is old. So honestly, it's prohibitive to deal with the legacy applications themselves. So we really just want to, enable this modernization with the infrastructure. And on that, if you want to chime in, Charlie? Sorry, Charlie's been sitting over. Charlie's our chief engineer, and he's a left-handed unicorn, and he's a whiz. So anyway.
Thanks, Berg. Yeah, so, kind of looking at what Berg just went over.
I can put that back if you want to talk.
Run it back real quick. So we talk about legacy applications, containerized applications, aka re-platform things we run in Docker, and then building true microservices. And so one of the things we talk about as the key enabler for all of this is the DevSecOps pipeline. The way we deploy legacy applications is typically through configuration as code, so we think about things like Ansible and Puppet. That's how we make sure that the configuration baseline is consistent when we deploy a legacy application to any environment. So there is a space in the DevOps pipeline for legacy applications to be maintained and operated. When we get into the re-platformed applications, most of us know about Docker circa 2015, but containers and the concept of using a Linux kernel go much further back, even to Solaris containerized zones. But fundamentally, the idea of running containerized applications is where we really want to isolate the resources and the processes running either in an edge environment or a cloud environment and make sure that the networking, storage, and compute are allocated and fundamentally supporting those services. So when we start moving from legacy virtual machines, bare metal deployed systems into re-platformed applications, our brain starts to think about running things containerized. So now let's take it another step further, microservices. So when you're writing microservices requirements, you really have to think functional. What is the input? What is the output? That is a microservice. And so a microservice is essentially one of the many services you see typically deployed in a legacy or a re-platformed application. A good example of this is something like Wildfly, JBoss, where you might see 200-300 different services responding to client requests for those re-platformed applications. What we're seeking to do through the microservices is take every single functional service, break it into a different pod or container, deploy that on something like Kubernetes at scale. And this makes everything a lot easier. O&M, ATO, defining requirements, what lives where and what it does. It's a lot easier when we talk about things as microservices and not as large siloed programs. That's really all I had for that, Berg. Maybe jump to the next slide and we kind of get into, I think, 8 areas of discussion. Yeah, so, this was meant to be a lecture, but it's also meant to be a little bit more of a conversation, right? So bi-directional between AWS and Leidos. We've got a lot of lessons learned over the last 2 years. One of those many lessons learned kind of moves into that next topic, which is AWS services and Amazon services, really understanding the differences between the two. Also a lot of lessons learned around Outposts. Many of you may be familiar with moving from commercial AWS to Gov Cloud or other AWS service instantiations. And you might have noticed that your APIs aren't the same across the board. And when you start learning how and why, that really starts to dig in the fabric of the organizational structure. What is pro services? What are AWS and Amazon services? And what's the delta there? And some of what are the roles of solution architects versus consultants on ProServe? So we really started working with AWS and learning a lot about how we work better together and how we make solutions happen for our customers. I don't know, Dave, do you have any thoughts on AWS versus Amazon? Not versus, but AWS and Amazon services?
Right. Yeah, so great point and great call out there, Charles. So in looking at the broad breadth of services that are AWS and Amazon, and making sense of not only the set of services that are applicable to you, but dealing with the dynamics of our approach from a service team perspective, dealing with multiple service teams, deal with multiple organizations in AWS. And sometimes you saw this full and in color, it all depended on which service team that was responsible for that particular aspect of the service, but sometimes the lines crossed. And there was a need to be able to have a conversation with multiple service teams that are associated with the capability that you're trying to get to, or that particular architecture that you're trying to get to. I think the Leidos E2C is a great example of really solutioning. It's starting with that capability, developing that architectural approach, focusing on the solutions, and then bringing in the services instead of upside down. Right. So I think it's a great demonstration of that and leveraging the breadth of what AWS and Leidos do together.
Yeah, we're really big on trying to take the problems and deconstruct it there. We want to solve problems, right? So I want to get there. So we do that a lot with potential customers as well. We'll do a lot of things on R&D. We'll talk to customers and be like, hey, what are the hard problems you're trying to solve? And then we'll go and help solve them. And then usually, go back and show the customer what we've done. So we're just big on that, and I know you guys are too. And you've been incredibly helpful. I think our relationship has been great. We've certainly, both directions, we've gotten a lot out of it. We talked to a lot of people on both sides. I think one of the things you were saying is every time we do talk to a new customer, that gets interesting because everybody has their own management of customers in there too. So that's one of the kind of lessons learned, and like learning how to navigate those things when we talk to, if we're talking to Space Force or Air Force or Navy or Marines, it's different people we end up kind of dealing with too, but we've learned how to navigate that very well, and I think
I think both of you pointed out just a few minutes ago to kind of the power of this partnership in creating something that's replicable. Yes, it may be customized a bit based on the customer environment and some of the unique requirements, but underneath, there is a point of replication there so that you can gain benefit of building it and then getting it broadly out into the market.
Absolutely. I mean, and that's one of the benefits of using the infrastructure as code and configuration as code approach that we've done. I mean, the DevSecOps pipeline we have can deploy the edge to cloud infrastructure somewhere. I mean, it's a repeatable code process, that we have there. And so, I mean, I kind of view edge to cloud as there will end up being different instantiations of it developed and installed in a variety of places, right? Each one maybe with a slightly, each one is going to have different applications running on top of it. But underneath, we've tried to make it easy to repeatably deploy it. And that comes into play, having the infrastructure as code comes into play for things like the IA process as well, like you were saying.
Yeah, and you honestly, you're hitting on the next three things here, right?
Yeah,
so we got professional services.
It's a conversation, right?
Yeah, we got professional services from AWS. So we just recently started working with ProServe directly. And one of the things I loved about working with them initially is the first meeting on day one, project kickoff, they said, here's our statement of objective, right? What's our SOO?
Yep, what do we do?
And I just really like that approach. I kind of sort of grew up in the more waterfall, traditional shall statement requirements world. And I started to evolve in the agile, more Scrum and Kanban-based methodologies. And so having that approach from Pro Services, it said, at the end of the day, what are you trying to accomplish? it was very refreshing. And then actually engaging with those teams, these are the consultants, dare I say, where the boots hit the ground, where the fingers hit the keyboards. These are the people that were able to really dig in and start writing the code, writing the test platform, getting into GitLab, making our runners operate. And it was just really, really great engagement. So if you've not used AWS Professional Services, or if you're interested in it, I highly recommend getting involved there.
I've been impressed with the way they run it, frankly. And again, the weekly scrums and meetings, it's been very professional.
Yeah, we call it a badgeless team at the end of the day.
Yeah.
Now, speaking of badgeless teams, Berg, I'm going to kick it over to you, but talk just for a second about the Office of Technology, the OOT. What is that at Leidos? What are we doing on the Office of Technology front?
Yeah, so real quick, like I said, I work in the Digital Modernization Accelerator under the Office of Technology in Leidos. The Office of Technology obviously falls under the company CTO, Jim Carlini. And so what we do in the Office of Technology is we span the entire company, right? Defense, civil, health, intel. And the Digital Modernization Accelerator, as you can guess, does digital modernization. And so, what does that mean? That means not only helping our customers be able to modernize in ways, again, modern DevSecOps, containerization, kind of cutting edge technologies. But how do we help the company itself do that as well? So the innovations that come out of the Modernization Accelerator, there are other accelerators within the Office of Technology. There's a software accelerator, cyber accelerator. There's kind of these different core competencies, core technologies that we're really trying to work on within each of the accelerators. And again, the idea is to disseminate that out across the entire company and enable the company to solve those problems for the customers. Right. In that digital modernization space.
Yeah, and one of our TCCs, technical core competencies, that Berg was referring to, is our Leidos software factories and our agile-based software development process, our mission-critical software systems. Software factories, it's a term thrown around a lot. Depending on who I'm talking to, they may or may not like the term. But what is a software factory? Well, very quickly, I'm from Charlottesville, Virginia. We have a software factory in Charlottesville. Most of our software factories are connected with the university, first of all. So Morgantown, Orlando, UK, Canberra, Australia. We typically are partnered with a university near us, and then we really build those relationships with the university and start to kind of develop what is our factory culture. What are we really focused on? So Morgantown, for example, very strong in Java Enterprise. They build a lot of Java-based systems and solutions. Charlottesville, we kind of come from the C++ world, so we kind of focus on more low-level code. But fundamentally, we all operate the same. So when a customer says, I have a fundamental problem space end-to-end, we bring that agile-based systems software engineering approach through the OOT across health, civil, defense, and intel. So while we've talked a little bit about edge to cloud earlier, and it's heavily defense-focused, and it really was something that came out of the Army, we operate across all verticals.
And as you were saying, the software factories are very well planned out too. We have a floor chart. If you want to build a new software factory, this is how you build
it, right? This is where the coffee pot goes here, right, and not over there.
Exactly. Get people together.
So, trying to switch gears. This is a hard one. We talked about this, but switching gears from the software factories, pro services, OOT, reducing the cognitive burden on the analyst, right? What are we talking about there? We hit that earlier when we talked about the tactical communications, between the layers. But reducing the cognitive burden on the analysts. When we think of an analyst, when I think of an analyst, I think of somebody CONUS, right? We saw that on the edge to cloud architecture slide, but one of the things you may not have pulled out very quickly was layers 0 and 1 is OCONUS, right? That's operational. Layers 2 and 3 are CONUS, and that's part of the federal acquisition regulations that any data center is in the 50 states and territories. So how do we reduce the cognitive burden between analysts OCONUS, analysts CONUS? Berg, I think you hit on this a little bit with running FMV analytics at the edge.
Yeah, those are the types of things we have to enable down closer to the actual analysts. Again, modern technologies as close as we can get them to help them make decisions. AI is decision assistance at its heart, really, right. And that's the kind of stuff we need to get out there. There are, again, a wide variety of applications of it. Again, from the edge to cloud perspective, we're trying to enable whatever you want to put out there to reduce that cognitive burden. Right. We're, again, kind of application agnostic as far as what's going to sit on top of us. Obviously, if you have containers, we are running Kubernetes across the entire ecosystem as well, and deploy containers. But like I said, with the legacy systems there, those are maybe just lift and shift into a standard EC2 instance. You know, we have to enable all those different kind of deployment methodologies there. But again, the goal at the end of the day is to help the analyst or help the end user. Again, we're coming from the DoD military world, so we are pretty wrapped up in you know, the soldiers at the edge or the airmen at the edge. I mean, we're in this. I know I've personally been in, and I know you are too, to really help DoD save lives, you know, at the end of the day. And part of that is speed. And if we can reduce the cognitive burden on the analyst, we can speed up the decision making and hopefully make better decisions as well.
The OODA loop.
Yeah, the OODA loop, the observe, orient, decide, and act. Exactly, yeah, move the OODA loop a little bit to the left here.
Well, we also know that in a DIL environment where comms are either denied or disconnected, two different reasons that can happen.
D-DIL, yeah, 2 Ds.
You do have a requirement to be able to make decisions at the edge, right? I mean, when, you know,
especially, yeah, if you're disconnected.
Rewind your military history, go back when comms didn't go OCONUS, you had to make decisions at the edge. And so we're kind of in a weird, not a weird, but a new sort of domain that is also an old domain, which is how do we make decisions at the edge with this modern technology? And you know, I'm excited I get to nerd out for a minute.
Yeah, go for the entry and out of tree.
Kubernetes, right? Entry and out of tree controllers. So Berg just mentioned, we're deploying Kubernetes across all the layers, right? Layers 0 through 3. So what is an in-tree controller? What is an out-of-tree controller? Why does that matter? Kubernetes has a special interest group, a SIG, and that's made up of a lot of industry partners that come together and talk about what the Kubernetes API should be. The Cloud Native Computing Foundation helps kind of support that to make it an open architecture. So when Kubernetes first started rolling out and you would install it, in that baseline code, you would get like an AWS built-in controller. So if I deploy a new application, I need to set up maybe a load balancer on AWS that allows ingress. The Kubernetes vanilla application would handle that for you. So fast forward a little bit, what did that mean? That meant that every distribution of Kubernetes had to incorporate new cloud provider APIs, new security patches, and it started to create this problem space where, you know, you need to upgrade Kubernetes in order to support a different cloud service provider or a different instantiation, as we talked about GovCloud, commercial cloud, other AWS cloud instantiations. So one thing that I've really enjoyed working with the AWS team is, you know, when I first started working with them in the Kubernetes world, I said, I'm not going to use EKS right out of the box. I mean, we use EKS, but I also want to deploy my own custom Kubernetes clusters. Okay, you know, why I wanted to use EKS or not, they didn't care. They said, fine, we're going to support you anyway. And that's where we partnered with Rancher Federal. And we wanted to deploy RKE2 clusters on top of EC2 instances. So what does that mean? Well, that means anytime I attach storage to a pod, whether it's in layer 0, 1, or 2, I want the storage device to be at layer 0, 1, or 2. And so that started to get into how do you use elastic block storage with Kubernetes. And sure, I could turn EKS, but as we get into things like Outposts in the DIL environment, some of your services like IAM that control your ability to make changes to the outpost, they're not necessarily available in a DIL environment, right? Because you're not connected to the cloud. So I can't necessarily depend on IAM, you know, for that disconnected operation. So the entry out of tree controllers conversation really is just to get everybody thinking about, if we're talking about using Kubernetes from layer 0 through 3, we can't kind of miss out on the notion that Kubernetes is complex and it depends on the cloud service provider. So whether you're using VMware, you're using AWS, you're using Azure, you're using Dell, Cisco, whatever, there's all APIs out there. And you have to think about when you deploy a Kubernetes cluster, what hardware is associated with it, what infrastructure is associated with it, and how is that cluster going to play well with ingress, for example, or storage.
Absolutely. And especially when we're deploying them across service providers.
Right.
I mean, that's where it gets complicated.
Yeah.
Right? But that's what we're trying to build.
Yeah, and again, so reducing the network bandwidth utilization with edge exploitation. One of the questions we always get is, I already have saturated network. You're proposing to put more on top of that, right? I'm going to push software over my tactical network. And it's like, well, yeah, but we're going to reduce the overall burden at the end of the day because, as Berg mentioned, things like FMV, I call it raster data, right? But your imagery it's already compressed. It's already taking up 60, 80% of your bandwidth. How do I exploit that data at the edge, right? There's all this noise coming in through these raw sensors. How do I filter that data and get the product out of it and then ship that back up to the cloud? Because at the end of the day, in an 8-hour video, I'm only interested in 5 minutes, right? So how do we push that to the edge? So I think we covered a lot of the bidirectional conversations. Let me jump to the next slide. I know we got a couple other things. We got a demo for you.
So one of the interesting things about building an infrastructure ecosystem is it's infrastructure. It's not the best demo at times of showing people infrastructure. Like, hey, this is the AWS console. It's awesome. There's all the things you can do. So one of the things we built actually in the Leidos software factory in Charlottesville, and Charlie oversaw this down there, is a tool called Otter. And it is a play on his last name, yes. But it stands for Open Technology Tracking for Enterprise Resources. And so what we're trying to do with Otter is basically give a command and control view of your infrastructure, right? And the containers that are also running on there too. So, kind of under the covers, we're hitting the Kubernetes APIs to learn what's going on that side. And so that's what we're going to show you real quick. Charlie will talk through that. And it does visualize our infrastructure that's out there, right?
And to be clear, I didn't pick the name.
Yeah, he did not.
It was one of the engineers who decided they would go with that and make my life wonderful.
So.
All right, let's jump in the demo real quick.
All right, well, it's playing.
All right, it's playing? Perfect. So what you're seeing is a common operational picture. So when I first started working with the teams, like, we're going to deploy Kubernetes everywhere. We're going to have operational personnel who have mission context. They understand commander's intent, and they need to think about when and where you're deploying your software. So right now, what you're seeing is a dashboard of a live edge cloud environment that we have. There's a Snowball there in Morgantown, one in Aberdeen, one down in Charlottesville. And as we zoom in, we actually notice there's a couple of clusters down there. There's also a Raspberry Pi cluster. And what you're seeing when we click on these different clusters are just the namespaces. So if you're not too familiar with Kubernetes, think of a namespace as just a logical isolation of resources for an app. So namespaces are basically applications, right? As we kind of go into the middle, though, you'll notice that there's a DoD sort of region. We call it our headquarters. And Otter itself is running in the HQ, right? That's the cloud. That's US Gov East in this scenario. We've got some other applications running here. MadCat, it's one of our command and control systems that help bring in metadata very quickly. And just a variety of other namespaces in here. So monitoring is key for a Kubernetes cluster. And what we've seeked to accomplish here is building a seamless dashboard so you can see where your clusters are and what their state is. We saw some lines connected there a moment ago. Those are physical routes. One of the questions I got from a customer recently was, okay, I see these lines connected, but what's actually going on there? Well, there's routing stations, there's fiber, there's coaxial cable, infrastructure that's buried that makes those things connect. But fundamentally, what you're seeing is a hub and spoke model, and those edge deployments are leaf nodes, right? They're just all the way out there at the edge. I made a joke last night. They file 0 on their taxes, right? No dependencies, right? They're just out there at the edge. And so that's when you think about what is an edge node, it is the resilient infrastructure all the way out there in the battleground, in the playing field, and they're the ones providing the final software
And again,
solution.
we're coming at it from the perspective that could be a whole wide variety of different types of hardware, right?
Yeah.
If we can deploy Kubernetes on it, we want it to be part of the ecosystem.
Right. You take Otter into some of the future requirements we have. Some of you may be familiar with Helm. It's the ability to automate deployments onto Kubernetes using infrastructure and service calls. If I were to pull that blue bar out, imagine a microservices catalog, right? Now I have the ability to do FMV exploitation. I have the ability to do different natural language processing analytics, you name it. I can literally drag and drop a microservice on this map, right? That's what we want to enable for the analyst. They don't need to be an expert in Kubernetes. They don't need to be an expert in tree versus out of tree like you all are now. They really just need to say, I have commander's intent. I have mission context. These are the nodes in my AO, and I need to push these updates. Sometimes it's a software security patch. Sometimes it's a pull, not a push. But fundamentally, we're trying to build this dynamic dashboard to really enable folks to not just look at, targets and sensors, and blue forces and red forces, but also look at the compute infrastructure that's out there.
Infrastructure itself, yeah. And again, we have to keep it simple. We do. We don't want people having to dabble around or learn Kubernetes just to be able to use something like this.
Right.
So yeah. Future requirements. I think we're doing network as well. We're going to start looking at like network bandwidth in between nodes. We can determine all that stuff, make that available to say like the applications that are riding on top of it. We're trying to enable also application development to change a bit in the way developers are thinking about developing apps for the edge.
That's a great point.
Right? Because it almost has to be edge aware. It's got to be network aware. It's got to understand what it can do, how much it can send, and making data like that from the underlying infrastructure available to the applications itself, I think is kind of a key thing for us to be able to do.
Yeah, I mean, you'll notice, I mentioned software factories earlier, Charlottesville, Morgantown, right? And you actually see those on the map. That's where our snowballs are. One of those nodes, it's just down and to the right of those two nodes close together there. That's where our outpost is. So one of the things we did early on with the outpost was we had the outpost, we had our edge network, right, the Leidos infrastructure, and we started putting these snowballs out there. And the question was, well, how are we going to go from snowball back up to the cloud? And what kind of rolled out of that infrastructure is, well, there's two routes. If you think like an SD-WAN perspective, you can go through something like 4G, 5G, commercial, ISPs, and go, what I could say, kind of all the way around over the top, back to the region through the region public services, internet IPs. Or I could use the outpost itself as a gateway. Now, of course, when I first proposed this, they're like, that's not what it's for.
It's an anti-pattern, Charlie. Stop doing anti-patterns.
But it was fundamentally understood very quickly. If I put something like a NAT gateway, if I do some routing, I can actually have my edge nodes work through an outpost as a forward deployed capability at layer 1, right? And then use that as a caching, landing zone, et cetera, back to the region. And so that's what you're really seeing here is our region, which is, Gov East, and then you're seeing the outpost connect to that region, and then you're seeing these hub and spoke coming off the outpost.
And but also to be clear on that too, so the snowballs, like the Raspberry Pis, are all on Leidos network. Obviously, GovCloud has its own thing, and then the outpost is sort of bridging those two, right? It's on the Leidos network, it's got a Leidos IP, but it's also directly plugged into the GovCloud region too. Yeah. So
it creates a great stomping ground for the engineers, right? The ones that actually built Otter. Their brains are starting to think about, how do I write software for a DIL environment? They're going to their customers and saying, I have no requirements here for what the software is supposed to do when it's disconnected. We're even working with some of our teams where they're like, I want to deploy my stuff, but I know what's going to happen when I lose connectivity to the cloud. I'm like, great, deploy it. I'm going to unplug it, and I'm going to show you. Right? The error log becomes your requirements at that point, right? Because it's like, these are the things that need to be fixed. So it's just really been a great overall relationship with AWS, right? Building the edge to cloud ecosystem, using agile-based methodologies, right? Kubernetes, and really just building Otter and getting to where we are today.
And yeah, all right. I think that's about it. We left a little bit of time here for Q&A.
Well, I'll finish with, we really appreciate the partnership, both Berg and Charles. It's been an incredible journey, even up to this point. And speaking for AWS here, we're really excited about the evolution of your vision, of what this opens up, what it creates, and then also the follow-on. I think you mentioned it. Whenever you start to provide services to the edge, other things become possible.
Sure.
And architecturally, different considerations become possible. So again, we're very, very happy and very excited to be working with you here in the Leidos C2C environment.
Thanks, Dave.
Yeah, Dave. And when you say all these different variations become possible, it made me realize, Berg, we did not even really talk about ATO and RMF.
Right.
How do you actually get an ATO for any of this?
We're partnered with Telos, so.
So Telos.
Go ahead.
Yeah, real quick. So Exacta 360, fantastic tool. It gives you the ability to put in all of your architecture and all of your, your ports and protocols, your services, your staff, your data types, everything that makes you run through a NIST 800. I think 838 is the generic NIST RMF. But to show how you're implementing your 171 and 53 controls. And when you think about something like edge to cloud, you got these 4 layers, right? Is that 4 ATO packages? Is that one boundary that kind of encapsulates it all? That's what we're kind of going through today. This is moving from IRAD to operations. And so what we want to be is turnkey. meaning that when a customer says, I saw your edge to cloud thing and I want to get that. Like I want to deploy that. Okay, well, how do you deploy that? Well, I always say if you can't secure it, you can't sell it, right? So working initially with some of those tools, on the DoD side, we have a system called EMAS, you may be familiar with, but you still have to submit these IA artifacts at the end of the day. So digging in on the infrastructure side, I say, okay, we've got Kubernetes, we've got GitLab, we've got Terraform, right? We've got Vault. We've got all these different pieces that make up this automated infrastructure. So from an engineering and a software perspective, everything's already turnkey, it's done. How do I get that updating the RMF framework? How do I actually get my engineers to know what RMF needs and is doing, and get it out of Excel spreadsheets, no dig on Excel, but get it out of the spreadsheets and make it to be more of an API-driven capability where if I do a new Kubernetes ingress or I deploy a new infrastructure as code-based VPC or subnet, tenancy is something we didn't also talk about, but like, is this a multi-tenant environment? Is it a single tenant environment? At what layer? We can go on this for hours, but I do want to make sure we all, you take away that the IA process, the ATO process, the RMF frameworks, that is all roped into this as well. So you're not going to get edge to cloud without going through the IA process, right? We're definitely hard with that, and security and resiliency is a big thing for us.
Yep. Security, resiliency, and scalability. So that's the kind of three tenets here.
Yeah.
So,
well, we've got some time for Q&A.
We do. I think we've got a few minutes left. 8 minutes for Q&A. Anybody? All right. Yeah, sure. If anybody has questions, we're happy to answer them, I think.
Any questions?
How you doing? Blake Kelly with Strategic Communications. Speaking on the resiliency topic, could you talk a little bit about how you've overcome the latency or timeouts of IAM for a field deployed outpost for a longer duration?
Sure. Now, I got to ask you a question real quick. Do you mean how do we deal with that as the integrator for the outpost, or how does AWS deal with that as an outpost service?
I'm interested in your answer, yeah.
All right, perfect. So IAM, you tied in RMF real quick there. So fundamentally, we start with identity, right? And we know that we have a DoD PKI, right, an infrastructure. We have CAC cards. We have online certificate status protocols that'll tell you if that CAC's active or not. So there's already an IAM out there. There's two pieces to that question, right? There's how do you tie in the IAM for authentication and authorization to control the infrastructure, and how do you tie IAM for the applications, right? What we see is two traditional models, right? We do a lot of modernization and cloud migration. So we get a lot of legacy apps that run their own database. They have their own users. It's all sort of internal embedded identity management within the application itself. And they quickly want to go on to things like ABMS, Cloud One, Army Enterprise. And so now we have to actually embed SAML into this legacy application. So there's a piece of your question, I think, that is really about how do you enable identity and access management for the applications. And that's typically done through, kind of going back to what we said earlier, customer by customer, unfortunately, right? Every customer has a little bit of a different set of IA requirements. So whether I'm talking to a 3-letter agency or a 4-letter DoD entity, at the end of the day, I have to go through their IA requirements and make sure they have their identity management track.
And it's definitely a mix. Like you said, it's still a mix out there for IAM across DoD, right? Like NGA runs a piece of software that does their IAM for them, but other agencies have started adopting that. Like AC2SP in the Army has started using that NGA tool that they're using, and so it does become this. I don't want to say cobbled together, but it's a very broad range of things that we would have to deal with. Yep. And again, edge to cloud itself is really just that underlying infrastructure, right? And there's those hard problems that will go on top of edge to cloud that we need to address.
No, I think to your question though, we just talked about application identity, and your question is outposts and the infrastructure, and how do you do IAM on that, right?
Right.
So we've partnered with AWS, and we've talked about this quite a bit. When the outpost loses connectivity, it loses connectivity to the region.
And you lose IAM.
And you lose IAM. So that doesn't mean the outpost is non-functional. It means that the services are degraded. So we've engineered and architected edge to cloud using our partners at Rancher Federal, right, to deploy Kubernetes on elastic compute. So that means if that outpost loses connectivity, the compute instances are still running, and they're still servicing the clients at the edge, which means that things like embedded IAM, things like Keycloak, application identification, that's still happening. Now, can I deploy a new instance? Can I modify the outpost while it's down and there's no connection back to IAM? No, but the Snow Family has their own IAM built in and baked in. So if I got a Snowball or I've got any kind of, EKS at the edge kind of capability, there's a lot of baked in redundancy. There's a lot of great new services coming through to support that kind of problem space. Did that answer the question?
Yeah, thank you.
Awesome.
Any other questions or comments?
Tough crowd.
Yeah.
Sir.
David with Adela Technologies. For your container images, are you guys leveraging another registry out there from another service? I know there's
Like Iron Bank?
Iron Bank, yeah.
Yeah. Yeah, absolutely. So, Iron Bank is.
We've had lots of discussions about Iron Bank.
It's one of the first, right?
Yeah.
It's the first say, come and put your stuff in Iron Bank and secure it, and industry can use it. One of the challenges with Iron Bank is there's no service level agreement involved. So let's say you start subscribing to an Iron Bank image as your solution. What happens when that image no longer has support? Well, it's not actually tied into your program. You just started leveraging it, and now what are you going to do? So I think that things like Iron Bank are phenomenal, great, progressive ways to get where we need to be. But I think the answer is going to be Iron Banks, right? There's going to be multiple repos out there. When we talk about the SecDevOps process, one of the JFrog has a Artifactory implementation called Artifactory Edge, which is a lower compute requirement Artifactory instance that you can deploy out to the edge and then cache all your containers and cache all your artifacts effectively to then make a deployment model. Think like 5G, right, kind of world. So the answer is, I think, yes. We've looked at Iron Bank and we leverage that heavily, in different portfolios. But we're also looking at it as it's Iron Bank, but let's be honest, under the hood, it's a Docker registry, right? And that's the most important thing, is to think about container registry and, again, open architecture, making sure that anything we deploy and do is interoperable with any kind of client image registry.
So it actually brings up a good point about the Artifactory Edge. I think at the end of the day too, our edge nodes are effectively, they're going to need to be a mesh unto themselves as well. So if we get into that detail, so Artifactory Edge is one of those things that can kind of enable that, right? I have a repository there that these leaf edge nodes could actually come and hit. Excuse me. If they're out in deployment or something like that. So maybe the mission commander, they need a certain suite of applications to go to this particular mission. I can come back, I don't even have to go back to the fob to be able to update my containers for another set of missions if we have something like Artifactory Edge on there. So that's one of the ways we're looking at the edge and starting to, again, we're still building edge to cloud. Version 2 is kind of coming over the next year. We've just been doing our planning for where we're going forward here. But
it's a good question. And again, we saw the Otter dashboard. I know we only got about 40 seconds here.
We do.
But kind of seeing the Otter dashboard, you think about where am I if I drag and drop, where am I dragging from, where am I dropping to? I think we've got a lot of future work in front of us, thinking about federated image repositories rather than just having one in the cloud.
Yeah.
And that's kind of like what we're working at now.
And I think a lot of places are trying to do centralized DevSecOps, and I'm not sure that's going to work over the long term either. I think you're going to end up with different instantiations all over the place. So, yeah. Go ahead.
Great. Well, I'd like to thank all of you for joining us in the discussion today. And our contact information is here. So if there are questions you have, things as follow-up here today, please take advantage of that. And I'd also like to thank both Berg and Charles for not only your partnership in this journey, an incredible and very unique solution space, but also for presenting here today at the AWS Summit. So thank you.
And there is an edge to cloud station at the Leidos booth too, where you can get maybe a little more in-depth briefing too if you wanted down there from some of our folks.
Yeah, as I mentioned, the Outposts, the Snow Family, you can see that at the AWS Hybrid Edge booth out on the floor. So definitely, if you haven't seen these, you can physically see it, touch it, and have discussions with our teams there. And lastly, please complete the survey. This is really important in terms of the quality of the session and the content that we're delivering. And again, thank you all for your time today. Have a great rest of the summit.
Thanks, everybody.
Thank you.